In this video, we're going to figure out how we can take some string that the user enters, like my secret message, and turn it into a seemingly random string of characters, like what you see over here. So we're going to use a encryption methodology called Base64 encoding. In this video, I want to tell you a little bit more about how Base64 encoding works. You don't really need to know the behind-the-scenes stuff to understand this, because at the end of the day, we're going to use a function built into JavaScript to do this conversion process for us. Nonetheless, I thought you might be kind of curious about how all this stuff actually works. So to understand how this encoding works, I want to imagine, or walk through the process really, of how we would encode the characters SEC, like so. So like really short for secret message, but I want to just think about the first three characters alone. Okay, so that's the goal. Now, as a little bit of backstory, I want you to understand two important concepts here. There are two sets of character codes that we're going to use to encrypt that string. The first one you need to be aware of is the ASCII character code set. So the ASCII character code set essentially is saying that the characters lowercase a through z, capital A through z, 0, 9, and a couple of other special characters can be represented with a decimal value from 0 to 127. So let me show you a chart that's going to help you understand what that's really saying. This right here is an ASCII character table. So it's essentially telling us that all these different characters that you see in red have a number representation that we can use to refer to each specific character. So for example, the letter S, which we said we want to encode, has an ASCII representation of 115. Lowercase e is 101, and C is 99. Likewise, there is also a set of character codes referred to as the Base64 character codes. So this is essentially saying something similar, but it's for very much fewer characters. So the characters lowercase a through z, capital A through z, and 0 through 9 can be represented with a decimal value as well. So those character codes are essentially from this table right here. So it's more or less saying that the letter S has a character code of 44, capital A is 0, and so on. So when we talk about encoding a string using a Base64 encoding, what we're really talking about is essentially taking the ASCII character code representation of a string, like the letters SEC, getting the numbers that represent each character, and somehow converting them into the Base64 standard, and then taking all of those numbers and returning them back to their original character forms, like the letter A, B, C, D, and so on. The thing that makes this process a little bit tricky is the fact that ASCII character codes can span from 0 to 127, but Base64 character codes can span from 0 to 63. So in order to make these two conversions kind of work together, we end up using a little bit of a trick. Let me walk you through exactly what that trick is. So we're going to understand this conversion process step by step. So we first start off with the letters S, E, and C. Again, that is the character sequence that we're going to imagine how it gets translated. So we start off with the ASCII character representation, and then we convert each of those into their respective character codes. So we get 115, 101, and 99. We then take those numbers and convert them to their 8-digit binary representation. So these are like the ones and zeros that we talk about when we imagine the very base or core level of computer programming. So each number gets converted into a binary representation. You can double check these numbers by just going online and doing a Google search for decimal to binary. So for example, if I wanted to convert 115, I could pull up a calculator like the one you see right here, put in 115, and I get out 0, 111, 0011. Now, the thing to keep in mind here, or notice, is that each of these numbers get converted into an 8-digit binary representation. So the next thing we're going to do is take each of those 8-digit representations and join all of them together, and we end up with a 24-digit of all those numbers joined together in series. Then after that, this is where we start to do the conversion process over to the Base64 world. So we're going to take that string of 24 digits and split them out into groups of 6 characters. So we end up with 4 groups of 6. So take a look at each of the binary codes here. Each of them are 6 characters. So here's the kind of conversion step. We then take each of these binary strings, convert them back into normal numbers, and then for each of these binary strings right here, we map them to the base64 table. So the big difference between the ASCII table and the base64 one is to express the ASCII table, we've got the 8 individual characters. But base64 gets expressed with 4 characters, or excuse me, 6 characters for each binary string. So we take these groups of 6 characters and we reference each of those on that base64 table. So for example, the 0111000, we can look that up on this table, and there we go right there, 0111000, we end up with a C. We then repeat that process for the next group of 6. So this one is 110110. Back over here, we can see 110110 for the number 2. And we repeat that process on and on. So we end up with the letters C, 2, capital V, and J. We then join those letters together, and that is our base64 representation of the string SEC. So that's pretty much it. That's how we're going to go from a string over to this kind of character encoding, and that's how we're going to do the actual conversion process. Once again, we don't have to do all this conversion on our own or by hand. Instead, we're going to use a simple function that is built directly into JavaScript to do this conversion for us. Well, like I said, I thought you might be curious about how all this stuff is actually working. Okay, so now that we've got a better idea of what's going on, we'll take a quick pause right here and start to do this conversion in the next video.